Right, we're looking at linear equations, grade 8 level, can also be grade 9, but these are linear equations where the highest degree of your variable is power 1. So if x to the power 1, a to the power 1, any variable, but the highest degree in linear equations is power 1. So let's have a look at how to solve these equations. First, very important, something that's going to come up that's crucial and important, an additive inverse. You would have been given under the chapter on integers that an additive inverse of a number or a term is that which, when added to that original number or term, results into 0. And basically, simple terms is just similar numbers with opposite signs, or similar terms with opposite signs, because when you add them, you get 0. For instance, look at these examples. 5, additive inverse is negative 5, and if you've got negative 12, additive inverse is positive 12, and if you've got a term that is 3x, additive inverse is negative 3x, and that's basically it. So you need to know that. We're going to talk about it when we're solving equations, linear equations, that is. Basic skills in solving linear equations. Now, one of the most important things in linear equations is that whatever equation you've got, you're trying to get to a stage where you isolate the variable that you're solving for, whether it's x or it's a, it's b, or any variable. You're trying to get to a stage where the variable is left only on its own with a positive on it. Can solve for a negative variable, solve for a positive variable. And that's one of the things we're going to be looking at in these next examples. Take that example, x plus 8 is equal to 12. In order to solve this equation, we would need to isolate the x. But now, to isolate that x, we need to get rid of this positive 8. To do that, we have to use a mathematically correct method, and that method is when we introduce an additive inverse on the left side of the equation for positive 8, which would be negative 8. We do the same thing on the right-hand side. And one important thing again, what you do on the left, you do on the right of an equation. So we would introduce an additive inverse of negative 8 on both sides. On the left-hand side, plus 8 minus 8 gives us 0, so we're left with x. But 12 minus 8 gives us 4. And we're done. We've literally solved our equation using additive inverses. Now, I've shown a whole lot of stuff there because I'm explaining where things are coming from mathematically. But if you look at this block on the right, that's basically what you would show, the necessary steps. There's no need to show us what's happening on the left. We already know it's going to give us 0. So you can show 12 minus 8 because you need to simplify that to give us the outcome of 4. Same thing here, x minus 3 is equal to negative 13. Definitely additive inverse is negative 7. So we need to add positive 7 on both sides because we need to deal with the additive inverse of negative 7. And therefore, that's positive 7 added on both sides, giving us x equals to negative 6. Very easy. Think about it. Don't make that error that people make every time. They just add the two constant terms as they are. That is wrong. If they are across the equal sign, you would need to use their additive inverse in order to simplify them. And there again, shortcut without showing everything and just show only the important steps. Let's look at another example. Negative 3x is equal to 18. Now notice now that negative 3 is multiplying the x. Unlike the previous questions where there was either addition or subtraction. So negative 3 is multiplying the x. You can't get rid of this negative 3 by adding positive 3. You're going nowhere. But now we have to use a multiplicative inverse. And the multiplicative inverse is simple 1 over 3 or negative 1 over 3, or you can also divide both sides by negative 3, which is the easiest one to actually go for. And say you're dividing both sides by negative 3 instead of saying you're multiplying by negative 1 over 3. So in this case, we divide both sides by negative 3. And the reason we're dividing by negative 3 is because we want to end up with a positive x. If we just divide by 3, we want to end up with negative x. So we get rid of both the 3 and the negative, and that then gives us x equals to negative 6. Okay, and that symbol you see there is the therefore, simply because equations are mathematical problems. So when we solve them, we get to a solution. So therefore, the solution to that x we're looking for is negative 6. That's what basically that is saying. And again, here's a shortcut. You can just show only the division on the other side because we already know the division shown on this side would have given us a positive 1. So you don't need to show us that unnecessary step. Here's another one, but this time around, notice that the 3 is dividing the x. And again, we use its inverse operation, which is multiplication. So the 3 is dividing the x, but the inverse operation is multiplication. So we multiply both sides by 3. And on the left hand side, the 3 cancels out, leaving us with positive x, and then 8 times 3 is 24. And we are done. And there again, here's the shortcut that you can show, which is easy to just show only that without showing other things. But just to show you where things are coming from, okay? Notice something that has happened here in all these examples. An inverse operation has been used every time. If it's addition, we use subtraction. If it's subtraction, we use addition. If it's multiplication, we use division. And if it's division, we use multiplication to get rid of numbers in order to get only the x isolated in your linear equations. Here again, we've got 2x minus 7 is equal to 5. Now notice here that we've got two things. There's multiplication of x, but there's also negative 7 there that is being added to the term. So in order to solve our equation here, we would need to get the additive inverse of negative 7, which is positive 7. So we've got 5 plus 7 on the right hand side, and we're left with 2x on the left. Now we can divide both sides by 2, okay, and x is equal to 6. Now just be careful, always start with the additive inverse and then go to the next thing, because as much as that can be solvable, it will be quite complex if you start dividing everything by 2, and that will complicate things there. But always start with the additive inverse and then follow with the other part of your equation. Here's another one. Again, additive inverse of positive 6 is negative 6. So we end up with negative 14, and then we divide both sides by negative 4. Now, negative divided by negative is a positive, but take note, we never leave our answers that are fractions in a form that is not in its simplest form. And the simplest form for fractions is that between the numerator and the denominator, there must be no common factor. So we need to remove that common factor of 2, and in the end, we're left with 7 over 2 as our answer. Never try and get decimals or some mixed fractions. Just leave your answer as a proper fraction. Let's look at the next one. Again here, get rid of the negative 3 by using the additive inverse positive 3. And now 9 plus 12 will give us 12. So the plus 9 plus 3 gives us 12. And then you multiply both sides by 2. And in the end, sorry, by 5. And in the end, x is equal to 60. Okay. So that's how you would work that one out. Look at number 8. Again here, you've got negative x over 7 plus 6 is equal to 3. Additive inverse of positive 6 is negative 6. So 3 minus 6 will give us negative 3, and then negative x over 7, so we multiply both sides by 7. But obviously, remember I said we don't solve for a negative variable, so you always need to leave your answer with a positive variable, and in this case we multiply both sides by negative 1 just to get the x to be positive. We're not worried about the other term on the other side, whether it gets negative or positive. We want just to make sure that the negative x is positive, and therefore our answer, x is equal to 21. That's it in terms of linear equations. There will be more in part 2 of this video, where you can look at more types of linear equations that can come up in your grade 8.